Hi, my name is Rogelio. I'm part of the Jest core team, and I work at Docker as a front-end engineer. So today we're here to talk about Jest as a platform. Well, what does that mean? Let's break that statement apart. First of all, what is Jest? Jest is a JavaScript testing solution which focuses on being easy to set up, providing instant feedback, and making sure it works out of the box. And what do we mean by platform? By that we mean something that is extensible, that works with your existing tooling, and that allows you to build on top of. So to better understand what we mean by Jest as a platform, we first need to understand what Jest is strongest at, which is testing. So we always go and try to add tests to a new application or project that we're working on. But down the path, we realize that we simply end up not writing them. A lot of this has to do with how hard it is to think of all the tools that surround your test. Because the higher the effort, the less tests that you're going to write. And the same is true for the opposite statement. If you need to think about how to wire all these tools together, then you're simply not going to write enough tests. And this is exactly what Jest tries to solve. It tries to make sure that you only need to think about one single test dependency to achieve all of that. The rest of the talk, we're going to be using this small application. It's called Emoji Cinema. And basically, you type in the name of a movie, and you get back its emoji representation. For example, if you type Frozen, you'll get a snowflake and a dress. And the way this application works is that at the very core of it, it has this searchMovies function, which takes in a query and returns an array of movies. For example, if you pass the letter F, it will return you all the movies that contain the letter F. And it's implemented something like this. It has an emoji map, and we're going to filter through it and return only the movies that match that given query. And our emoji map looks something like this. And if we take a look at our project structure, it would look something like this. So let's go ahead and add Jest to this project. The first thing that we need to do is to add Jest to our dependencies. And from there, we're good to go. So let's go ahead to our project. And in this case, I already went ahead and set everything up. And let's start Jest in watch mode, and let's see what happens. As you can see, Jest didn't find any files. So let's go and create a test file for the searchMovies function. We could searchMovies.test.js. Jest will pick it up, rerun our test, and tell us that that file doesn't have any test. So let's create a test for it. It returns the movies that match that given query. And it also expects searchMovies of F to equal some set of movies. And as we start saving it, Jest reruns the test. And if we modify our expectation, Jest will give us a pretty printed diff of why our test failed. So this is the quickest introduction to Jest, and we barely scratched the surface of what it has to offer. And if you're interested, I totally encourage you to go to its website to learn more. So now we're going to go to Jest as a platform, but before we do that, let's see what we got from Jest. We got an immersive watch mode experience. We got tests that run really fast. We got a great user experience, a deep Git integration, and all of this with zero initial configuration. So now that we all know about Jest, let's go ahead and talk about the platform aspect of it. For this, we're going to be looking at it from two different perspectives. The first one is to be able to cherry-pick specific features of Jest and use them as standalone packages. And the second one, which we'll talk more about later, is to be able to put your tooling on top of Jest and leverage its features and infrastructure. So let's start by talking about cherry-picking features of Jest. Up until now, we've been looking at Jest as this single package. But if we zoom into it, we'll realize that it's composed by several independent packages, each of them allowing you to cherry-pick a small feature and use it as a standalone module. And if we take a look at a couple of them, we can start taking a look at JustDiff, for example. Remember that when our test failed, Jest gave us a pretty printed diff. Well, that was powered by JustDiff. And you can get all that diffing algorithm that Jest uses as a standalone module and use it in your application. It will even work with deeply nested objects or any other serializable value. Now let's take a look at Jest validate. I actually really like this one because it's great for validating anything that has a config. And in fact, this is what Jest uses for validating its command line arguments. So for example, here we have a config that says watch equals true. And if we want to validate it, we simply need to provide Jest validate with an example config, and it will do the rest. So now if we change the value of watch, it will give us the appropriate error. And it's robust enough that it allows you to inject links to our documentation or even deprecate some options. In this case, we're deprecating watch in favor of superwatch. So that's how we cherry pick specific features of Jest. But now let's take a look at how we pull our tool on top of Jest. This is great because it brings Jest features to your tool. And to better understand what this means, let's take a look at the life cycle of a test run. This happens in 3 different steps. First, Jest will find your test files. Then Jest will run your test. And in the end, Jest will report the test results. And as you can see, a lot of the heavy lifting is happening when Jest is either finding your test files or reporting the test results. So imagine if we could swap that middle part, also known as the runner, for our own tool. That means that Jest would do all the fancy work for us. And at this point, we've been talking about Jest as a platform, and we introduced the concept of runners. But how does this look in practice? I'm sure that maybe at some point, this point, some of you are thinking, like, sure, Jest is nice, but at work we have this Mocha code base. And even if we wanted to migrate to Jest, we do not have the resources or the time to do that. So imagine if we could keep Mocha as our test framework and leverage Jest for the rest. This means that we could leverage Jest features across an entire code base without changing any lines of code. Let's take a look at how this actually works in code. Here we have our same Emoji Cinema project, but in this case it's using Mocha instead of Jest. So let's go ahead and add Jest and our Jest Mocha runner. And then we're going to tell Jest to use that given runner. And then if we go back to our project, which I already went ahead and set it up with Mocha, and in this case it's using the assert library to make it work with Mocha, we can go ahead and start Mocha, and let's see what happens there. So our test passed. Now we can go and start Jest in watch mode again. And we can see that Jest will pick it up and run the Mocha test and report back the results. And as we make changes to our expectation, it will give us that pre-printed diff with the appropriate error. And every time that we make changes, Jest picks it up and runs all that Mocha tests. And because it's leveraging Jest infrastructure, it will even work with code coverage out of the box. So if we can swap the test framework, and it means that we can probably use it for more than that. And the cool thing here is it works for a lot of use cases. And for this, we are going to need to start thinking about Jest less as a testing platform and more as a tooling platform. ESLint is a great tool that we all use. And it's also a great example for this, because it could leverage Jest watch mode and parallelization. In fact, Airbnb started using this a couple of months ago on their CI. So in order to add our ESLint runner, we need to do the same thing as we did with our Mocha runner. We simply tell Jest to use that runner. And in this case, we're also giving it a display name to have a nice identifier when we run our tests. And we're also telling it to look at all the JavaScript files. So if we go back to our project, which I already went ahead and set up to use the ESLint runner, let's go ahead and start Jest in watch mode. We can see that it found those 3 files and it reported the corresponding ESLint errors. And as we make changes to our file, Jest will rerun those ESLint files and report the remaining errors. And again, because it's leveraging Jest infrastructure, you can even use the filtering mechanism that Jest has to only run ESLint at a single file or at any other files that you are filtering by. So if we can use these for Mocha and ESLint, it probably means that we can use it for even more things. For example, we can use it to run Python tests. Here is Jest running Python tests. Over the last couple of months, several runners by the community have emerged, and each of them are at different stages of their development. So we've been talking a lot about runners, and it seems about time that we write our own runner. In this case, it's going to be a Blade Runner. So imagine that we have this company policy that requires each and every file to have these two emojis. This means that if a file doesn't have them, our test would fail. And if it has them, then it will pass. So to better understand how we would implement such a thing, let's take a look again at the lifecycle of a test run, and specifically at the runner part. First, Jest will give a list of files to our runner. Then, in this case, Blade Runner will spin up independent node processes for each test file. In each of them, it's going to check for the presence of the emoji, and then it's going to report the results back to Jest. And this happens mainly in two different parts. The first one is the entry file, which is what Jest is going to be talking to. And the second one is our worker file, which is in a run.js file, and it's going to get spinned up independently on its own node process for each test file. And as you can imagine, there's a lot of complex parts happening in between these two. For example, handling test interruption and keeping Jest up to date with the status of each file, spinning up workers and cleaning them up, and reporting the test results back to Jest. So for this, I created Create Jest Runner, which basically encapsulates all of this complexity, where you simply need to provide a path to your run file, and Create Jest Runner will take care of parallelizing it and orchestrating everything behind the scenes, and spinning up those independent node processes. So now that we know the different parts, let's go ahead and implement our Blade Runner. We'll start with our entry file. Remember, this is what Jest is going to be talking to. So it's going to be fairly simple. We simply require Create Jest Runner, and we give it a path to a run file. And now let's take a look at our run file. This is going to be a function that, among other things, it receives a test path, and it will return the test results. Remember, this file gets instantiated once per test file. And in this case, we're simply going to check for the contents of that given file. We're going to check for the presence of the emoji, and then we're going to report back the results. And Create Jest Runner also provides you with a pass and fail function, which they simply normalize all the data to the format that Jest is expecting. So now that we have our Blade Runner, let's go ahead and try it out. Here I have our same project. So let's go ahead and start Jest in watch mode. We're telling it to only look at the searchMovies files. But you can see that none of them have the emojis, so it failed in both of them. And as we start making changes to our files, it will only report the changes for that given file. And all of this is leveraging Jest watch mode and parallelization. So that was Blade Runner. So you might be asking, like, what's next? This is just the beginning of Jest as a platform and of runners in general. They still need time to evolve and mature. The future applications of this are way wider than what I showed. That's why I'm extremely excited about this. It's an open area of research. I'm happy to help out if you have any questions. And thank you very much.